Hello, my name is Mirissa Garchar, and I am a freshman in the Honors College at West Virginia University, majoring in psychology and neuroscience. My research takes place at the Human Performance Laboratory of the Rockefeller Neuroscience Institute of West Virginia University, which focuses on the improvement of the lives of athletes, clinical patients, as well as the general public. My current study focuses on the use of wearable devices to measure acute stress response as quantified by heart rate and heart rate variability in healthy individuals. Heart rate is a physical measure of the state of the autonomic nervous system. This is comprised of the sympathetic and parasympathetic nervous systems, which indicate physical states of arousal and rest, respectively. Heart rate variability represents the interaction between the sympathetic and parasympathetic nervous systems and provides a non-invasive measure of physiological response to stressful stimuli. Advances in wearable technology have provided simple, non-invasive methods to accurately measure changes in heart rate and heart rate variability over time. Researchers are able to observe these changes with the introduction of a stressor such as the cold pressor. Given that heart rate and heart rate variability provide reliable and non-invasive measures of physiological stress response, the study at hand intends to observe changes in these measures in response to the cold pressor as a physiological stressor. An ambulatory 3-lead ECG was used to measure participants' heart rate variability. Electrodes were placed below the left and right clavicle, as well as in a left intercostal space. A polar H10 heart rate monitor chest strap was used to measure participants' heart rate. The cold pressor, a cooler of water set at a temperature of 3 degrees Celsius, was used to induce acute stress. Participants endured a 5-minute rest period to establish a baseline, followed by a 5-minute period in which their left hand was submerged in the cold pressor up to the wrist, and a 5-minute rest period to return to baseline. This figure displays the change in heart rate during the 3 phases of data collection: before, during, and after the cold pressor task. The results indicate an increase in heart rate during the cold pressor task, as well as an increased resting heart rate after the stimulus was removed. This graph displays heart rate variability data from the same 3 phases of data collection. There was a significant decrease in heart rate variability during the acute stress response, and heart rate variability was significantly higher after the stimulus was removed. The results of the study supported the hypothesis, which predicts that during acute stress, physiological symptoms of heart rate will increase and heart rate variability will decrease. Thank you for taking the time to view my presentation.